Going to look at the game changers. I heard that mentioned hydrogen. We've been talking about hydrogen. Tomorrow will be a whole day of hydrogen. So let's deep dive into where we can look for those game changers in the hydrogen economy. I'd like to welcome on stage, if they are ready, and I think we're still setting up for them. We're going to have Ivo Bowles, who is European President at Air Products, Kim McCann, who is Head of Sustainability, Global Industrials and Manufacturing at PA Consulting. Lord Adair Turner is joining us. He is Chair of the Energy Transitions Commission. And Jochen Steinbauer is joining us as well. He is joining us virtually, though. He's Platform Director at H2 Technologies for Regional Trains at Siemens Mobility. If I could ask the group to step up on stage and we can jump straight into a conversation that seems to be hot topic and topic du jour right now. Thank you very much for being with us. I would like to start off with you, Kim, if I can. It's suddenly very hot again. Hydrogen, it's suddenly come back, and it's come back with a bang in the last 2 years. What happened?
Climate change.
That's been around for a while.
That's the short answer to that. If our energy system of the future is being built on capturing the wind and sun and the windy and sunny places in the world and transferring it to where all of the energy is consumed, which don't tend to be the sunniest and windiest parts of the planet, then you have to be able to transfer that energy. And right now we turn that into electrons, we turn it into electricity, but you can't transfer that over very, very long distances, and you can't really store it at scale over very long distances. And there is also a lot of the energy stack that electrification just can't reach. There's the really intense industries. There's the really intense transportation systems. There's shipping, there's aviation, there's steel, cement, glass production. Unfortunately, electrons aren't going to help us out of that, but hydrogen is. I think we forget that even in hydrocarbons, we never get the energy from the carbon molecules. We've always really got all of our energy from hydrogen. It's just how we capture it and move it around.
If you can run us through your thoughts on the conversation suddenly really gearing up with hydrogen, especially in the last 2 years. What's changed? How are you approaching it? And where is it going to lead us?
Yeah, so first of all, as an industrial gas company, hydrogen has been in our portfolio and pretty dominant in our portfolio for the last 60 years. And I agree with you. The interest, look at this room, look at the conversations, is significantly different. And if you say, why is that? I think, first of all, because a lot of influential people in politics or industry start to take climate change very serious, whether forced or by choice, but that is fact. You heard our CEO earlier on. This is an industry view, but if you look at the different platforms of discussion, people are now at a stage they look for solutions that work. If we look at hydrogen and look at it as an industrial producer of hydrogen, it is a molecule that, as Kim already indicated, will be part of the energy transition mix. You will need something to address some very essential processes that support societies as they operate today. And if we say, is the technology there to achieve that? It is. We can do this. It is something that is within reach. It needs choices to be made. It will need infrastructure to support it and to make sure people believe they can trust it as they rely on different sources of energy versus what they did before. But I think it's feasible. You can see the roadmap. It is getting the political support or the government support, because governments are responding to what their electorate wants. Mm-hmm. And with that, I think you start to get a very strong momentum for it.
Jochen, is there the technology? Is it being used? Is the belief system there? Will you be using it across Siemens?
Yes, exactly. Especially for Siemens Mobility. I look back to the year 2017 when we started the development, and we could not even spell the word hydrogen. And during 4 years, now we're in a stage of manufacturing trains. So this development was growing, and the market was growing at the same time. So we believe in hydrogen technology, especially for heavy-duty applications, and this can be a contribution to be sustainable in the future and totally replace diesel engines from the trains.
Lord Turner, you are part of this conversation. You're leading this charge, that you're leading the conversation regarding all of the fuel mixes that we need to have to transition to net zero, do it in a nature positive way. What about hydrogen strikes you most, that it needs that push and that government support? What is it?
Well, if I could just comment, because it's relevant to this, on this question of why are we suddenly talking about hydrogen, and it's grown over the last 4 years. One of the reasons is that we've got serious about net zero. And once we got serious about net zero, we had to have an answer to how do we get to net zero in the harder to abate sectors of the economy, like steel and aviation and shipping and petrochemicals and long distance trucking. And 3 years ago, the Energy Transition Commission, which I chair, produced a report called Mission Possible, which said even these sectors of the economy can get to zero by 2050. But it's when you get to these sectors of the economy, which, as you've already said, you can't just electrify them. We haven't got batteries, energy dense enough to take ships from Rotterdam to Pearl River Delta. We haven't got, or to take planes from, London to New York. But hydrogen is a hugely relevant mechanism. It's the way to the decarbonization of steel, of shipping through ammonia. And it's these emergence of this demand for hydrogen to decarbonize these hard-to-abate sectors of the economy, combined with the collapsing cost of the crucial input, which is renewable electricity. I remember we're now dealing with solar PV, 85% cheaper than it was 10 years ago. Wind, including offshore, 70% cheaper than it was 10 years ago. And there's only two things matter to the cost of producing green hydrogen. It's the cost of your electrolyzers, and it's the cost of your renewable energy. And the renewable energy has come down, the demand, the potential demand has gone up, and as a result, we are now seeing a collapsing price of the electrolyzers. Now, the biggest challenge going forward, I actually think now, is accelerating the demand even more. I think we're in a situation where we now know how to produce green hydrogen at amazingly low costs compared with where we were 5 years ago. There are absolutely credible people saying that whereas it costs today maybe $5 a kilogram, they can get it as low as $1.50 a kilogram by 2025. I heard the Chilean Minister of Energy saying that at a session on Saturday. But the challenge now, I think, has switched from, we now know how to produce relatively cheap green hydrogen. We know that it will be required in very big quantities in the 2030s and 40s. We need to pull forward some of that demand. We need to really drive the early demand development in the steel sector, in the chemical sector, in the shipping sector, to make sure that we're going forward with a balance between the supply and demand here.
Kim, how do you do that? When you speak to your clients, do you push them towards it? Do you tell them explore this particular option? It is a solution for meeting your targets?
So it comes down to two things, really. One, innovation just isn't physical technology innovation. Business model innovation has to go hand in hand with the technology innovation. So you need to be able to look at the business models. Because as Lord Turner said, yes, the price has collapsed, but you're still pretty much making electrolyzers by hand. It needs to continue to come down because there is still a price premium. And many of those end users at the moment can't absorb that cost on their own. So you've got to look at that business model end to end. And that brings me to the second part, which is partnerships, which is actually looking across the value chain from producers to end users, moving together to be able to do things. You're seeing recently, last week in Wales, one of Budweiser's breweries is going green hydrogen. Here in Scotland, after the energy sector, our whisky sector is our second largest emitter. You're seeing green hydrogen be used with our distilleries now as well. So getting across the value chain, getting partnerships across that value chain, and focusing on the demand sectors first, where there is some weight within the margin to be able to take it. An extra few pounds in a bottle of a very nice single malt whisky is not going to be that much harder. It will be if you're going into aviation, where an airline works on 6% margins. Their largest cost is their fuel, and they've covered their cost of capital 4 years over 40. So you don't start in aviation, you start with those that can actually take it early on.
You seem to echo almost the thought process of the Icelandic minister as well, that you start with a smaller area and then you start expanding out. So how, Ivo and Lord Turner, do you kickstart the market? How do you push these industries? What kind of incentives do you give them to start looking at it very seriously?
Well, one of the things we've got to do is encourage end buyers to buy the intermediate product or service which buys the green hydrogen even when it's at a premium. And for instance, this is the US driven initiative called the First Mover Advantage Alliance, which is trying to get major buyers of shipping to be willing to say, I mean, it applies shipping and steel and all the different sectors, but let's take it in shipping. It's trying to get the Amazons of the world or the Walmarts of the world or IKEAs of the world to say, we stand ready to buy shipping services, even if it is a bit more expensive to start with, in order that the big container ship companies, Maersk or MSC, can then say, okay, I will now invest in ammonia burning or methanol burning, it could be either, ships, to create the demand for green hydrogen. So I think these are very useful starting points. I will say that I think they're only starting points and that you do have to reinforce them by some combination of carbon prices or regulation. So I was talking with the International Chamber of Shipping the other day, and it was very clear that very strong support that although we can get the thing going with these people who are willing to play the green premium to get it going, ultimately we need the International Maritime Organization to either impose a carbon tax or to say it will in future, or to impose what's called a fuel mandate, a mandate that says by 2030 or by some future date, a certain percentage of the fuel burn has to be zero carbon. So we need to start with these early customer buyers, and we are seeing that. So Volvo Trucks is now making commitments to buy green steel from SSAB out of the hydrogen reduction plants that they are building in Sweden. We are seeing this pattern emerging around the world, and we've got to maximize that, but we've got to follow it up with regulation and carbon prices as well.
Eva, you wanted to follow up on that?
Yeah, maybe a couple of points to add. Obviously, you could call it chicken and egg, but on the one hand, you say demand is important, and I'll come back on that. The other point is availability of the molecule. You mentioned the term first mover. As Air Products, that is what we do. Yeah, we are a first mover, not just announcing thoughts and ideas. We are actually building the largest green hydrogen facility in the world for now. Others will follow. We believe that that is essential because quite frankly, we do not see this as any constraint. There will be significant demand. And actually, all the different sources of hydrogen production will be needed if we want to get close to the targets we're setting ourselves. Now, if you say, look, are people actually reacting and thinking rationally in an economic way? You mentioned the carbon tax. I mean, it is one of these pressure tools within industry, going from fast leading companies to maybe lagging companies and technologies that need to adjust. But that sort of creates this momentum and the requirement and the appetite and interest to do the energy conversion. We believe as Air Products that in our own way we have a critical role to play because we believe we are, as you said, not necessarily in the sunniest place on Earth. On the other hand, there are places where indeed you can rely much more on the natural resources of sun and wind. That is not only for competitive reasons to say what is the cost of your hydrogen, but in the first place because of the reliability it offers, the percentage on stream. And within that supply chain, if you say we want to top up, we want to kickstart with imported hydrogen, you will have a supply chain that has resilience, that can actually have a proposition for people that is reliable, forecastable, that they can say, okay, that is something I can work with. So first movers are needed, both on the production, but also on the demand side. And just to complement the comments made was really around what do we expect from government, apart from facilitating? It's also stimulating demand.
Stimulating demand, indeed. So I'm going to bring you back, and we lost you briefly and your connection very briefly, but we have you back now. So one of the comments that has been made is that we need to kickstart some demand, generate some demand, and convince consumers that it's worth it, and start it from there, and then move on and progress. If you're looking at a hydrogen-powered train, how likely is it for a consumer to be okay? And I ask this out of sheer curiosity. How likely is it, in your experience, to sell a hydrogen-powered train to a TfL, for example, and get them to pay a little bit more than what a normal diesel-powered train or an electric train would cost?
Yeah. From our perspective, and this is our daily work, and this is the daily discussions we are having with our client. They are not in a position to pay more than for diesel trains at the moment, and that's indeed really a problematic. That's the reason why we need to push from outside. We need the governmental support by covering gaps in the prices between diesel train and, of course, hydrogen trains. And even we need to, of course, balance the supply and demand, but we need to be carefully decide for which application we really use hydrogen. And for heavy-duty application, like for trains, for example, a fleet of 40 trains covering 1,000 kilometers per day, we require 10 tons of hydrogen per day. And this 10 tons is increasing the demand, and the increasing demand is increasing the supply. So, and this is how this market gets started. But for other applications, like cars or applications requiring less than, for example, 400 kilowatts, at the moment it doesn't make sense. And even for applications like aircrafts requiring more than 4 megawatts in power, even this makes no sense. So we need to really carefully decide which are the right applications to start this market growing. And from our perspective, trains are the right arguments, but they need to be politically supported by governmental funding, because the gap between diesel trains and hydrogen train is enormous in the one-time investment, but not in the life cycle. For the life cycle, in the life cycle of 30 years train operation, the investment is returned, but not in the one-time investment. And this is exactly the point where the politicians and the government needs to step in.
So if I can go to Lord Turner and then to you, Kim. You wanted to respond to him?
No, not particularly.
Okay, then Kim wanted to respond, for sure.
Yeah. So to that point about government incentivisation and how that works, so you're seeing it happen already. If you look in Spain, for example, the way that hydrogen is being implemented in Spain is generally in industrials. It is in things like the glass industries and those sorts of things where people are getting a 10 megawatt of electrolyzers and a solar array and off they go. In the UK, what you're seeing is actually transport's moving first and road transport's moving first. And the reason for that is because the way it's being incentivised here is through the mechanism of credits that we've got. Actually, it's reusing what was used for biofuels, called RTFO, Road Transport Fuel Obligation. But you're seeing the credits come back to people through ground transport. And the other thing you're seeing is the public sector move its heavy fleets first. So you're seeing Glasgow go with its garbage trucks. You're seeing bus fleets go. So you're starting to see the public sector be that catalyst, that start of it. The second thing, to Joachim's point around the right amount of uses and the right use cases, the thing with hydrogen is it is a bit like electricity in that it's not a single use case tool. You know, Edison invented the light bulb and got electricity there. Did he think then all the different uses we have today for electricity? It's sort of the same with hydrogen. You have to start in hubs. If you start with that one place where you've got your bus fleet going back to or your garbage truck fleet going back to, and you start from there and create a hub of uses around it, then you get the economies of scale where it does start to make more sense for certain uses.
I think it's also important for us to back the ones that we're absolutely certain or very close to certain, nothing certain in life, but pretty close to certain, that they will be very big on the long term. So if you take the road transport thing, I just don't know where the divide is going to be, the dividing line between electric and hydrogen fuel cell. I'll tell you for a certainty, there are going to be almost no hydrogen passenger cars. That is one of the reasons you were asked first, Kim, you know, we used to talk about hydrogen, and suddenly we're talking about it. Hydrogen, conversation about hydrogen went off in a cul-de-sac, which was thinking that hydrogen was important because of passenger cars. Hydrogen is important in lots of sectors of the economy, but not passenger cars, right? Passenger cars are electrifying. A lot of mid-duty, mid-sized trucks are also going to electrify. I think the bit that we don't know is the dividing line in the heavy truck arena between what goes hydrogen and what goes electric. And if you talk with the major truck manufacturers, I was talking yesterday with Volvo, that they're backing both technologies and they don't know what the balance will be. On the other hand, I am as certain as most things in life that steel is going to go hydrogen. I'm pretty certain that shipping will go ammonia or methanol. I'm also certain that hydrogen will play a hugely important role in the power system as a way of dealing with what I now know has the German name, a Dunkelflaute. A Dunkelflaute is a period of time where all your renewable supply goes down. You know, suddenly there's an anticyclone in the North Sea. You've got lots of offshore wind. For 3 weeks in the middle of winter, you haven't got the offshore wind, just at the point when the residential heat demand for electricity is highest. And I think we will use hydrogen as a balancing item within the power sector. But just to give you an idea of the scale of this, we think that hydrogen is currently about 100 million tons a year. We see a world within 3 decades where that is 500 or 600 million tons a year for a variety of industrial and other end uses, including long-distance transportation like trains where we don't have the line electrified, plus several hundred million on top of that 500 and 600 million used as a balancing storage mechanism within the power system. So this is a massive scale of development that has got to occur, but we should certainly support a whole range of demands, but I think we should focus in particular on the ones which we think can really be big ones in the long term.
Well, that brings up a question from our audience. Amar Nader is asking, and it's quite relevant to what you were just saying, from a manufacturing perspective, what is the roadmap looking like for the use of hydrogen? Is there a roadmap, a clear global one? And especially in heavy industry, he's asking, is there even a framework available to discuss a pilot case or a lighthouse base case? So, Ivo, you were talking about being that first mover. If I can get all of you to give me an idea if you think there is an actual roadmap out there that's globally applicable.
Well, I think we as Air Products, we believe and we put our focus, first of all, on mobility. All aspects of mobility, as was commented here, for a variety of reasons, because with the supply of hydrogen and the availability, it can have a significant impact and it can have a structural impact in terms of where is hydrogen available. And back to some of the points made, if you see that on a cluster basis, that is most likely how the infrastructure and the availability will evolve. Once you have that ecosystem, then it becomes interesting for industries that can participate in that to go higher scale, higher demand, and support bigger processes. The obvious ones have clearly been mentioned. Steel, possibly cement, chemicals. There's a pretty logical chain to see where is the conversion cost and at what point will these industries convert. The only point I want to add again is this will only work if we have a reliable supply chain. I come back to the same point. Today, there's significant hydrogen production, but it's only a shadow. It's minute versus what is required tomorrow. We have opportunities to improve the performance of the current infrastructure producing blue hydrogen. That is important because it is an accelerator. It can be there, it can be available. It allows people to convert, get the whole infrastructure in place before you have enough green molecules that you can either source locally or import. So this cluster approach, the availability, and then combined with first mover producers, first mover consumers, with support from the government to make sure that they get rewarded for being leaders and first movers, is where we see the important first steps on the roadmap.
Kim, you wanted to come in.
So yeah, everybody wants a single roadmap. Everybody is looking for that because our energy industry today is built on large global optimized supply chains. I've spent 25 plus years optimizing supply chains and 15 of that in the energy industry. And this is the biggest change people have to get through their heads. It is not going to be a silver bullet, one size fits all big supply chain anymore. You have to think of it more like a neural network with those nodes. And it's as much about the existing infrastructure, the geography of where you are and what you have there, as well as the industry around it that could be the demand that will make it much more demand supply. So it will be in hubs and in nodes, but there is no one size fits all. I keep saying hydrogen and even electrolyzers at the moment is not off the peg. Everyone's a haute couture, designed bespoke dress.
Well, if everyone can afford that, they should definitely have that, correct? Lord Turner, at some point when you're talking to people around the world, you know, the Australians are very excited about their part in this whole process. They're driving quite a bit of the agenda. But when you talk to others who are more on the front lines of climate change, are they willing and ready to think about the investments into hydrogen as a potential answer to some of their energy needs? Fiji, for example, or some of the other countries who might be looking for another source to go fossil-free. The Iceland minister suggested that perhaps the smaller countries are a good place to start.
Well, I'm not sure that the production of hydrogen will be focused on many of these vulnerable countries, and I'm not sure it needs to be. I mean, let's be clear, you take Fiji, you take the island communities, the one thing they don't have typically, usually, is residential heat demand. As they get richer, they'll have air conditioning demand, but air conditioning will be pure electric. The ships that go there, you know, need to be in hydrogen and ammonia. Any aeroplanes that go there, we've got to have a solution to that. But, you know, we're unlikely suddenly to see steel production or chemical production moving to those sort of locations. It will be dominated, at least initially, by the major developed countries, plus India, plus China, and other major, you know, middle-income countries, Brazil, Indonesia, etc. So I think to go back to the question of roadmap, and people get very worked up about this debate between blue versus green. So just to get the figures clear, right at the moment, of the 100 million tons, 97 is grey, and about 3 is green, right? 97 is made from methane with steam methane reforming without carbon capture and storage attached. And only about 3 million probably is made from electrolysis, order of magnitude. And that is why the electrolyzer industry, as you said, is a cottage industry at the moment. It's not on scale. On the other hand, I think the scale is arriving on electrolyzers, and as a result, the cost is collapsing. I mean, on, you know, the variety of cost at the moment is absolutely startling. There are people still, you know, old contracts for electrolyzers could be $800, $1,000 a kilowatt, but there was a new contract to deliver Chinese electrolyzers in China to Huaneng Group, the big electricity provider, at $250 a kilowatt. So we are seeing a collapsing price of electrolyzers precisely as we turn it into a mass manufactured product produced in those sort of things. But I do agree that we have to have, and we believe that eventually green will dominate. Our scenarios are ones in which eventually of that 500–600 million, 85% or so will probably come from green. On the other hand, we have a whole load of SMR plants in there at the moment, and it makes absolute sense to add CCS to them to create blue hydrogen by converting grey to blue. And we should also, in the roadmap, start with some of the big existing demands for hydrogen. One of the biggest is ammonia that goes into fertilizer. So greening the global fertilizer train by making sure that the ammonia that goes into urea fertilizer and the hydrogen that goes into that is zero carbon, I think is one of the really important starting points to get this pathway going.
There are two questions that have come in. I will let you choose which one you want to address. Catherine is writing in and asks, does Lord Turner see, well, this one's for you, Lord Turner, does Lord Turner see a role for hydrogen in domestic heating? I think it's based off your previous comment. And Fabrice is asking anyone on stage and virtually joining, Jürgen, considering the low efficiency of electrolysis and fuel cells, does it still make sense today to use power to gas to power? So, Lord Turner, if I can ask you.
On domestic heating?
On domestic heating and hydrogen.
I don't know. I think it is still open-minded. I've just been down to the end of the hall there, and there's a kitchen hub which is going to run on hydrogen. I was rather disappointed. I thought it might have a hydrogen supply, and I'd be able to sort of, see how well it, fried my onions or something like that. But it isn't actually connected. I suppose the fire regs don't allow them to do that. Look, there is an uncertainty. If I had to guess, I think a lot of the way forward with electricity, with a residential heat, will be heat pumps in those housing situations where you can go heat pump. Because remember, the magic of heat pump, and people say, when you first say it, this sounds like an impossible, like a perpetual motion machine, is you put in 1 kilowatt of electricity and you get 3 kilowatt hours of heat out, because you are sucking heat from the external air. It's an air conditioner pointed round the other way. And I think that fundamental advantage probably means that in the long run, where physically easiest in a reasonable size semi-detached or detached house with a bit of space at the back, where physically it's easier to put in a heat pump, I think we'll probably go heat pump. Mm-hmm. But there is much of our housing stock where it's not easy to put it in, and I think it's there that we're more likely to see hydrogen blending into the network, conversion of our boilers and cooking to hydrogen. So we'll see. It could be either. I put residential heat in the sort of don't know category versus the steel or shipping, where I put it in the almost certain category.
What category do you put it in?
Rather than I don't know, I'd say it depends. So it's back to that network and that hub effect thing. So, for instance, in Germany, where our colleague Joachim is from, you have a lot of closed gas networks. You have a lot of closed-loop gas networks near large industrial clusters. Yep. So where you have a source baseload off-taker that is an industrial off-taker, yep, it will then make sense because, yep, you have a closed-loop network you can inject in and blend into, yep, to be able to get the housing around that to go. We don't have much of that in the UK. But what we do have is a lot of leaky old Victorian housing where passive heating systems, which is what heat pumps are, don't work well. They work, yep, well in a hermetically sealed box. They do not work well in housing that is designed to be drafty. These houses were designed to breathe in the Victorian era. So for those, there has to be something, especially in a Scottish winter in a Victorian house. I don't think underfloor heating would kick it. You're going to have some form of on-demand heating as well. The fact that you can blend in at 20% blends is helpful without having to go through the billions of upgrading the gas network. But again, the consumer is the one most price conscious, the most pocket conscious. Yep. So you need to have some form of hub close by that will the industrial will almost subsidise, if you like, the heating that would then go around it.
So Ivo and Jürgen, I'm going to put Fabrice's question back to you. He's from H2 Power. He's asking, and I'll repeat the question since we might have forgotten, considering the low efficiency of electrolysis and fuel cells, does it still make sense today to use power to gas to power? And especially in context of what you do.
Yeah, so...
yeah.
You can go first.
Oh, sorry.
Yeah,
so
okay, good, thank you. Yeah, that's exactly the point. And you asked the question before, you asked about development, and we are just only talking about the supply, but we need to also talk about a development roadmap for our hydrogen subsystems. And indeed, the efficiency for electrolyzer systems and fuel cells is very low at the moment. And I'll provide you an example. The well-to-wheel efficiency of a hydrogen train is roughly about 25%. For a diesel train, it's 30 to 35%. So we need to have a development roadmap on fuel cell, on electrolyzer systems, and all the other hydrogen subsystems. And at the moment, I do not see any, but we require one. We require clear targets for improving and upgrading the efficiency rates, for increasing the power density of the systems. And let me provide you another example. For the storing of hydrogen, we use cylinders. Cylinders is not the optimum way of using the volume we have available. So there needs to be developments in fuel cells, in efficiencies, in power densities, and then back to the question, then power to X and back X to power. Then this could be an application, but at the moment it's not the right time for that. It's just the right time to use what we have, improve it continuously, and get it onto the market.
Either?
Yeah, if I can, I would like to add if the key objective why everybody is here is actually to reduce CO2 emissions. And it is really about saying what are the tools we have and what is the hierarchy we see in how we apply the alternatives. And if we talk about the green power or the green energy that we generate in the region, let's talk here about Scotland. Where are you going to direct that green energy to in the first place? Where does it give you the highest gain in terms of decarbonizing and reducing emissions? I think there are relatively clean and clear priorities where that power should go in the first place, like other evident measures like insulating your Victorian homes, which may actually be money very well spent if you want to decarbonize the world. The point I want to make is there will be a balance and there will be choices to be made because in the years to come, there will be less hydrogen than the potential demand. So it's very important that depending on what is critical for each geography, for each country, as my fellow panelists already indicated, they will have to sort out what their priorities are. And they may be different depending on location, availability, and as I indicated, what kickstarts you? Yeah? How can you actually come to serious size on a cluster basis or on a distributed basis, but make sure you make best use of your electricity, of your hydrogen, of your biogas to decarbonize and reduce your emissions to get to your targets.
We have literally 1 minute left, so closing thoughts, and also if anyone has a really cool, innovative person, organization, company that they've heard of, give them a shout out so people can actually pay some attention to this. I met a woman called Vieta Cohen who won the Earthshot Prize for an amazing electrolyzer design. So if that could be possible, I'll give you an extra minute there, and then I think our team will just have to deal with it. If I could start with you, Lord Turner. Closing thoughts.
Well, I want to make the closing thought that if we are to have huge amounts of green hydrogen in particular, we need huge amounts of electricity. And just a key point to realize that in terms of the total amount of investment required, it's not in the steel mills, it's not in the ships, it's not even in the electrolyzers, it's in the electricity system. If you have 500 million tons produced from electrolysis, right, at, what should we say, 45 kilowatt hours per kilogram, that's 22,500 terawatt hours of electricity. The total electricity production in the world today is 27,000 terawatt hours. This is a huge demand for electricity. And actually, what happens in the grid is crucial. If you talk to SSAB, the Swedish steel company, about what it would take to accelerate their current plan to get rid of all their blast furnaces and to replace it by hydrogen-based DRI steel, the answer is agreement to a new transmission line, right? So things that have to happen in the electricity system are absolutely crucial to support everything that's going on in hydrogen, if we assume that the majority will eventually come down the green route, not the blue route.
Kim, closing thoughts?
So I think we've spoken a lot about blue and green, but actually there's a lot of other really cool innovators out there with different colours. There's pink, which is with nuclear, which might be a solution for some of those electrons. There's also turquoise,
Turquoise.
which is really interesting as well, which is taking it from methane and it's completely zero emissions. You end up with carbon black and hydrogen out of methane. Those are really cool techs to pull out. But the company that I would give the shout out to is actually Proteum Solutions, which is a UK-based company. Chris Jackson, the CEO of that, is really pushing the green hydrogen agenda and really getting that value chain piece moving. And I think if we see more people focused like that on bringing the value chain and the end use together, and we really innovate the technology around that to scale it up, that I think is really the way forward to accelerate.
Thank you. Eva.
Yeah, coming back to the point, I named our own company as a first mover. I think for this energy transition, it needs a first mover spirit. There will be risk, there will be uncertainty, but people at some point need to jump. If we focus on the transportation market, someone will have to produce the trucks, because even if people want them, they will need to get access to them, and at the end of the day, they transport goods, and they have to transport those at a very acceptable cost for the consumer. So there's plenty of opportunity for people that once they see the light, to jump and start doing things. I think as an industry, from the supply side, we will continue to move, we will continue to make steps, because as a company, we are convinced that sooner or later, it is difficult to say, but the opportunity is huge, and it is us as a global citizen, that is what we have to do. And we see plenty of other industries that actually are doing remarkable things. So if you create a platform for them, as you do here, that is exactly what we should keep doing. Bring those minds together. I think they can come to interesting, landmark solutions that can be copied by others.
Well, you should be here tomorrow then. It's Hydrogen Day. Jochen, give us your final thoughts.
Yeah, thank you. In summary and in perspective of Siemens Mobility, I do see three fields of action. The first is we need local hubs for supplying different applications with hydrogen. The second is we need a clear development roadmap for hydrogen subsystems, like increasing fuel cell systems efficiency and so on. And the third is, in order to reduce the price gap to the diesel trains or for diesel applications, there needs to be a push from the outside in terms of governmental support and funding. These are the three fields of actions we still need to consider, and then I'm pretty sure and I'm pretty confident that will definitely grow.
Thank you to all of you for your thoughts. I think tomorrow we'll pick up on where you have left us in this conversation. There's so much to discuss. So I really appreciate you sharing your thoughts with us and, of course, leaving us with those ideas. Especially, Kim, thank you very much for the rainbow of colors that you left us with. Give them a round of applause, and we will continue the hydrogen conversation tomorrow.